Okay, so we begin. We are on the front page. It's marked question number 14. This is a nightmare. I'm juggling myself. Okay, so this is a perfect example of why you need to read every statement. Because number 14, we all want to go to A. The value of r squared shows that there's a strong positive linear relationship between the length of the year and the mean orbital radius. Sounds good, right? We look at r squared, it's 0.98, very high. We think there's a linear relationship. However, we're presented with a scatter plot. And the scatter plot clearly shows that while r squared indicates that there's a strong relationship, it's clearly not a linear relationship. And therefore, statement A is most likely not going to be the best choice. So we continue on. B, the residual plot shows that there's a strong linear relationship. That's flat out wrong. The residual plot shows a clear curved pattern to our residuals. We don't want to see that if we believe there really is a linear relationship. Part C, the slope of the regression line. So I come up to my equation. The number with the variable will be my slope. It's positive. The slope of the regression line shows there's a negative association. That's not correct. This is a positive slope, so a positive relationship. So let's look at D. The regression line underpredicts the length of a year for a planet with mean orbital radius 100 million kilometers. Well, the lowest value on the graph is 1,000, so 100 would be very close to 0. I notice that all of my data for 0 is above the line. Recall, if our data is above the line, then the line underpredicts. And if our data is below the line, it overpredicted. Our data at 100 is over the line, which means that the regression line underpredicted, and D is the correct answer. Next, ladies and gentlemen, it is extremely important that you're able to identify the three most important pieces of information from a computer output source. They will be the coefficient constant, which is your y-intercept, the coefficient with the variable is your slope. And again, we're not interested so much in the number if we're not asked for an equation. It's more the sign, the positive or negative. And we are interested in our r squared, not the adjusted r squared, just the r squared. Which of the following is the correct about the correlation coefficient? I notice that all 5 of my statements start off with r equals. So I need to get my r value. I'm going to do that by taking the square root of my r squared. The square root of 0.407 is 0.638 plus or minus. I don't know. So right off the bat, I am going to eliminate answer A, and I'm going to eliminate answer B because they do not have the correct r value. Okay. I don't know if my r is positive or negative just based on taking the square root. What I need to look at is the slope. If the slope is positive, then r will be positive. If the slope is negative, r will be negative. The slope here is 0.5566. That is a positive number, so I know that my r value is positive as well. So I can eliminate letter E because that shows a negative r value. So now I need to decide between C and D. Statement C says, because r is 0.638, so 63.8% of the variation in the Boston on-time performance is explained by the least squares regression of the Boston on-time performance on Atlanta. They are giving me the interpretation not of r, but of r squared. That is the interpretation for r squared. They're giving me r value and then interpretation of r squared. That is not correct. Letter D, let's hope it's correct because it's the only one I haven't found something wrong with. God bless you. Letter D, r equals 0.638. So according to the least squares regression line, a change of 1 standard deviation in Atlanta's on-time performance corresponds to an increase of 0.638 standard deviation in Boston's on-time performance. That is a correct interpretation of r. Though it's one we didn't focus on, I did give it to you in the notes. I tried to give it to you in the helpful hints. R goes, let me step back a second. Slope, a change of 1 in x tells us how much change we can expect in y. That's for slope. For r, a change of 1 in x standard deviations tells me how many change in standard deviations I can expect in y. So it's a very slight difference between slope and R interpretation. Slope deals with the actual units themselves, whereas R will tell me about the change in standard deviation. So letter D is the correct answer. A residual plot. This was straight out of the notes. A displays residuals of the response variable versus the independent variable. It's the residuals of the response variable versus the independent variable. Letter A is correct. Next, a National Consumer Magazine reported the following correlations. Correlation between a car and a car reliability is negative 0.30. That negative is just as important as the absolute value. And the relationship between car weight and annual maintenance is positive 0.20. Heavier cars tend to be less reliable. So car weight and reliability, it's negative. Negative means as one goes up, the other goes down. So that is a true statement. As car weight goes up, reliability goes down. Correct. Heavier cars tend to cost more to maintain. So let's go to the maintenance one. It's a positive relationship. As one variable goes up, the other variable goes up. So as cars weigh more, their maintenance weighs more. That's correct as well. True. And statement 3, car weight is related more strongly to reliability than to maintenance. Reliability has a 0.3 as an absolute value. Maintenance has a 0.2 as an absolute value. 0.3 is closer to 1 than 0.2. 0.3 is closer than 0.2. Therefore, the maintenance is less related. The reliability is more related than maintenance. So reliability is more than maintenance. This is also a true statement. So I'm looking at numbers 1, 2, and 3, which is letter E. Next problem. In the context of regression analysis, which of the following statements are true? A, when the, number 1, when the sum of the residuals is greater than 0, the model is nonlinear. That statement just is nonsensical. The sum of the residuals is always 0. Sum of the zeros is never greater than 0. It's always 0. Okay? So just because they add something to a nonsensical statement doesn't ever make the nonsensical statement true. It just doesn't make sense. That statement's just flat out wrong in the beginning. A random pattern in the residual plot indicates that linear regression is appropriate. Yes, we want to see that randomness. We don't want to see a pattern. We want to see random. So statement number 2 is true. And influential points always reduce the correlation coefficient. That is incorrect. Outliers always reduce the correlation coefficient. Influential points can in fact strengthen the correlation coefficient, but it's not necessary that they reduce them. So that is a false statement. We could say outliers, but it's certainly not true for influential points. So the only true statement was number 2, so B was the correct answer. In the context of regression analysis, which of the following statements are true? A linear transformation increases the linear relationship between variables. A linear transformation preserves the relationship. So it doesn't increase it, it doesn't decrease it, it doesn't change it at all. It just preserves the relationship that was already there linearly. So that is a false statement. A logarithmic model is the most effective transformation method if the data takes on a logarithmic pattern. But if the data doesn't take on a logarithmic pattern, then a logarithmic model would not be the most appropriate. So that's true only some of the times because they say they don't have any kind of clarifying word. Like sometimes we have to say that that's false because it's not a definitive always term. And a residual plot reveals departures from linearity. That's exactly what a residual plot does. It shows us how far off was our predicted from what our observed from what we had predicted. So number 3 is true. That makes letter C the correct answer. Number 2, my helpful hint here was to draw a line through the data. Give yourself an approximate value. We want to know which points would decrease the correlation coefficient, the coefficient of correlation. That means which one would weaken our linearity. So we want to get rid of the 2 points closest to our line. That would have been 2 and 4. Are 2 and 4 an option? Yes, letter E. And last but not least, number 3, this was a two-way table, conditional probability. Remember, anytime you have a two-way table, you want to be very careful to pay attention to your denominator. 600 travelers have purchased airline tickets through the same travel agency. The following table gives the two-way classification of their destination choices. What is the joint relative conditional frequency? Conditional tells me that they're limiting my denominator. For female travelers to Asia. So we were interested in travelers to Asia, of them who were female. So of my travelers to Asia, I have 111. Of them, 62 were female. So 62 out of 111 is 56%. That concludes the homework solutions to bivariate data. Thank you.